Okay, guys, y'all want to see any of these? I guess I need to give y'all the key, right? Let me bring it up instead of printing it off because it's. Let y'all look at it and see if y'all got what the key says. Let's see if this is the right one. So here we go, guys. This is the key. This is the first page. So y'all look it over and see if y'all want to see any of these. This was the first page. I don't know yet. Huh? Okay. Oh yeah, this was it. So which ones? Find this page. This is supposed to be the first page. Huh? Yeah, the first one's just an inverter. Okay, y'all look at them and see what y'all got. Find this sheet right here. I don't know what page it is. See if I can make them a little bigger. Still keep them on the page. Yeah, I can. That's about as big as I can make them, guys. It didn't print? Okay. Oh yeah, I told you for some reason, that's why I redid them, but for some reason, one of the other ones went on top of it. It's what happened. Are we okay? So I redid how I redid the sheet. Ready to go? Everybody ready to go to the next sheet?
No.
Yeah, if y'all want to see any of these, we'll go ahead and do them. It's up to y'all. Oops. This must be the second page. That's right. Or A page. Got an or and negative and negative. Okay, we ready? Okay, so here's the last one, along with the circuit y'all was supposed to do, but most of y'all didn't do that. This guy here gets a little harder because you're trying to keep up with 4 inputs. Of course, the trick I gave y'all was to come in and shade all the what's active, right? And it makes it a lot easier to line up. I noticed some of y'all had done that. This makes it a lot easier to figure out. What's that? What we're doing, and I don't know what you mean. What we're trying to do on this right here, I wanted y'all to try to figure out what I had to put on the input to get the output to go low. Now, and what I'm trying to show you, or what I was going to try to show you, is the difference between positive logic and active logic. Now, and this is what I told you. If you see this, if you see a low active input feeding a output feeding a high active input, then that means something is not quite right here, right? You understand? So of all the combinations, this is 1, 2, 3, 4, 5, 6. That's 6. So that's 64 different combinations we can put on this input that would cause the output to go high, but I'm not asking for it to go high. I'm asking what's required to cause it to go low. You don't understand? So, first of all, I need this right here to go low. So what do I need to put on the input of a NAND gate to cause the output to go low? Come on, guys. All highs. Okay. Well, one of them's tied high, so that doesn't make any difference, right? You understand? So it's high all the time. So that means I need to get 2 highs out here. Well, this one's pretty obvious because this gate right here says all highs to get a high, so that's okay on pin 13, right? You understand? But then I run into a problem because this gate does not say, if I look at this symbol, it does not say all highs to get, it doesn't say, it says all highs to get it says any high to get a low. But I'm not trying to get a low right here, I'm trying to get a what? A high. So this is not serving the function of this circuit. This is not serving the function of a NOR gate. It's serving the function of a negative NAND, right? You understand? Yes or no? And what I'm trying to do, so this is the exact same circuit. Look, the part numbers are exactly the same. This is a 74LS32. This is a 74LS32. This is a 7427. This is a 7427. This is a 7408. This is a 7408. But the problem is, this one down here is drawn in active logic. This one up here is drawn in positive logic. I want to get a low out. So what did you have to do? You had to come up here and try to figure out how to get a low. And what most people did is put all ones over there because they looked at the symbol of the gate and not looked for what the circuit was looking for, right? You understand? So what's this circuit looking for right here on the output? What does it want on the output? It wants a low. But instead of looking this at what I was requiring on the output, you came over here and looked at these symbols and put all ones over there. And so what happened is that you misinterpreted what the circuit was looking for. Now this one, odds are most of y'all got this right if you tried it, because this is in active logic. So the gates are drawn depending on what the output of the circuit wants. So the outputs of the circuit, we want a low. It's got a low active output. So the 7410 is right. Right now, look over here, I need a high right there. To get a high on this input, I need a high active output, right? You understand that? So I flop the symbols around. So now I can come over here without even thinking about this circuit. I can come over here and put what the gate says it wants to. What do we have to do over here? We have to figure it out. Right? Y'all understand? So which one would you prefer the way the circuit to be drawn? Well, hopefully you'd prefer it to be drawn this way. But believe it or not, they're not all drawn that way. And that's what I like about the circuits in the back of the textbook. Some of them are drawn all positive logic, and some of them are drawn in active logic. And you'll see the active logic is a lot easier to figure out. Unfortunately, they're not drawn that way. But what you have to do is you have to understand that the positive, we have two symbols for the same circuit, right? You understand? We have what we call positive logic and negative logic. And how do you define them? Well, the negative logics are going to have low active inputs. The positive logics are going to have high active inputs. And it don't make any difference what the outputs are. The output does not determine if it's low active, if it's negative or positive. It's the inputs that determines where it's negative or positive. It's just like people jump on this symbol right here and think this means it's a NOR or an AND, but it don't. What determines if it's a NOR or an AND is the active state of the input is opposite of the active state of the output. But we'll have somebody, I'll put this symbol on the test and I'll say, and somebody's going to call it a negative NAND. Because why? Because it's got a bubble on output. But that's not what determines if it's a NAND or a NOR. So this is a negative NAND right here. This is a negative AND. Not because the bubble's on the output, because the active state of the input is low, the active state of the output is low, right? You understand? So that's the worksheet, guys. This is and if you can understand this, you're doing really good, really well on the basic logic gates, even though there was a couple of them that wasn't on there. Are we okay? Anybody got any questions on this? Yes or no? Okay, guys, we'll be in lab to about 7 o'clock, and then we'll start the test at 7. Y'all 2 hours to take the test. Give y'all something to look forward to.